Okay, welcome, Gabby and Colin. Thanks for coming, and hopefully we'll get a few others that to show up to this because we actually have a lot of things to talk about and some important things that are coming up. So let me share my screen and talk about the plan. Okay, so let me tell you the plan for today. We'll start out with any questions you might have. And then after that, we're getting into hypothesis testing. And just to let you know, chapter 9 is all about hypothesis testing. Chapter 10 is all about hypothesis testing. Chapter 11 is all about hypothesis testing. Chapter 12 has a little bit of hypothesis testing. And chapter 13 is all about hypothesis testing. Okay. And actually 10 actually has a little confidence intervals too. But so basically, this is what we're going to be doing for the rest of, just pretty much for the rest of the whole class, the whole course is hypothesis testing. So if you have any questions, please stop me because you need to get this down or the whole class won't go well for you because this is what we're doing. So today is day 1. It's the introduction to what a hypothesis test is. And a lot of you've all seen it, but you didn't necessarily have the word hypothesis testing. You saw it in 7th grade. I'm sure that's the last thing you expected me to say. But they call it something else. Anyone know? Yeah, scientific method. Yeah, so they call it the scientific method, and that is hypothesis testing. But for statistics, we use the special words hypothesis testing, but it's the same thing. So we're going to get into the process of hypothesis testing. And just to let you know, the order at which you do things is not optional. You have to do them in this order. So sometimes you have to do them because if you don't do them in the order, you can't do them. And the other piece actually is sometimes it's unethical to do it in a different order. So we'll talk about that also. So I'll start out with the first thing you do hypothesis testing, which is the null and alternative hypotheses, which are basically your idea. You know, you think this is true. Let's write down what you're trying to show. Then you're going to get into type 1 and type 2 errors. And that, the idea of that is because you're just taking a sample, the sample may end up being misleading. Okay, nothing you did wrong or anything, but you might just get an unlucky sample. And because of that, you could have an error. And you might have heard the type 1 and type 2 errors in medicine, especially in like pharmaceuticals. Do you know what they call that? Those kind of errors, the 2 errors? It happens when you get your COVID test, for example. Yeah, false positive and false negative. Okay, but in statistics, it's type 1 and type 2 error. So again, you've heard of some of these things, just not necessarily in the statistics way. Then we're going to get into the level of significance. And that's kind of like the confidence level. So it's how okay you are with being wrong. Has to do with the level of significance, but it's a little more complicated than the confidence level. So we'll get into that. Then we'll get into the p-value. And the p-value is all about how certain you are of being right. So you run your analysis, and that'll give you a probability that your thing would just happen without you being right. Kind of that idea. Then we'll talk about how do you state your conclusion. So just like a confidence interval, you had to write down what the confidence interval meant. Here you have to write down what your conclusion is. Similar ideas. Then we're going to interpret the p-value, and a lot of writing, by the way. Figured I should let you know, give you a little warning. So we're going to interpret the p-value. We're going to interpret the level of significance, and that's important. And then project 2. So you're not really ready to do project 2 yet, but I want to give you some ideas of what it's about. Next week when we have confidence intervals and hypothesis testing for the difference between two means, that's when you'll be fully ready for project 2, because that's what project 2 is going to be about. But I can give you some kind of thoughts about project 2 today, even though we're not covering that until next week. That way you can kind of get started, even though if you don't quite know all the details. So that's the plan, because a lot of people like to get started early. So I want to make sure that I get you going. So that is the plan for today. So let me ask you, are there any questions about anything that's come up? I finished grading your exam. So, take a look. I believe you get a notification when I put a note in Canvas so read what I put in. You should be able to look at your test and then see, if anything went wrong, you can kind of see what happened. Any questions about anything? Again, I'm always happy to answer questions. Kind of a big point of these webinars, versus just the hour-long videos, is that you guys can ask questions and we can communicate that instantly. Whereas if you're watching an hour video, you can't really do that. Any questions at all? Any questions about anything? Okay, if there aren't any questions, then I'm going to talk about hypothesis testing. And by the way, if you come up with a question later, that's fine. Pop it in. You can put it in the chat, or you can ask it. We're being recorded, but the chat's not recorded. But again, no one really cares anyway. No one watches. It's not like some other YouTube videos where everyone watches it. This one is really not watched, except by you guys. So what we're going to be talking about now is hypothesis testing. What hypothesis testing is all about is you have an idea. You think something might be true, and you want to provide evidence to show that it's likely to be true. Okay. One thing you never do with hypothesis testing, or confidence intervals, by the way, is prove anything. Right? We're only providing evidence for truth. We're not proving it's true. And a great example of that, this happened to me. It was some years ago, but I got jury duty. Any of you got jury duty? And we had to make a decision. Okay, we had to make a decision. I am allowed to publicly say what happened. So it was a woman in the backseat of the car, and there was a big drug deal going on. And the big question, they found a big bag of drugs in the passenger seat. And the big question is, was she going to be part of this drug deal that was happening, or was she just a passenger? And we had to make that decision. So one thing you can't do is you can't prove she was guilty, and you can't prove she's innocent. Okay, that's not doable. All you can do is provide some evidence. And that's what hypothesis test is all about, is you're providing evidence, you're not proving anything. You're providing evidence so that you have a convincing argument that it's very reasonable or very likely that it's true, which is very different than saying it's true. Any questions on that idea? Yep, beyond a reasonable doubt. And in fact, for beyond a reasonable doubt in our class, okay, by the way, they did not ask me this when I sat on the jury. In our class, beyond a reasonable doubt means typically if there's a 5% chance that you're wrong, or a greater than 5% chance you're wrong, then you pretty much say that's not beyond a reasonable doubt. If it's less than 5%, then you usually say that's beyond a reasonable doubt. Sometimes you change that percent. We'll talk about that today to 10% or 1%, okay, or some others. So when we're doing hypothesis testing, it's really all about that kind of thing, is that you have evidence, not proof. And the question is that good enough evidence to kind of stake your reputation? And that's kind of what you're doing. Any questions on the idea of why we do hypothesis testing? Okay, let me give you another example, kind of the most important example that's come up in the last 2 years. Okay, it's come up in multiple slightly different ways. And that happened, so it started out about a year and a half ago, actually. What was the big thing that the entire world was hoping for and also worried about? Yeah, COVID, and in particular, did the vaccine work? So what they had to do, okay, and I'll tell you, the details, because I wasn't part of it, by the way, other than the part that, I did get vaccinated, but that wasn't really the test. What they had to do is they had to decide whether or not this vaccine was effective and safe. Does that make sense? So what you don't want to do for a vaccine, for example, is open it up to the whole world and give everyone a shot without testing it. How come? Yeah, bad reactions, or how about death? Okay, remember, it's new. They didn't know anything. They didn't know what happened in a couple months. So you can't do a study of the entire population, and that one you really couldn't, because you end up killing the whole human race, which probably be a bad thing. So what they did is they were able to get volunteers, and I'm not sure if you know the details. They actually used Israel. Israel was the group that they used. Israel was first, okay? But that doesn't mean it was developed in Israel. It was developed in America, but they kind of used Israel as the big test. And fortunately, it didn't kill them all off, which is good. So they had to do a sample. And then based on the sample, they had to decide whether or not they were confident enough that it worked. And one of the problems is that most people weren't getting COVID. So you can't just sample one person, because if they don't get COVID, that doesn't mean it worked, because they probably wouldn't get COVID anyway. Does that make sense? Okay. The 0 to 5-year-old is not done yet, actually. And we'll talk about that at the end, actually, because there's some very, very important but minor details that make it very difficult for the 0 to 5-year-olds. But for the adults, it was still difficult, but not as difficult. So what they did is they were able to get volunteers to be part of the study. So they had a sample size, and of the people who got the shot with the vaccine, anyone know what the sample size was? Like I said, I've studied it all, so I do know these. Yeah, 20,000. So 20,000, and they gave 20,000 people the vaccine shot, and then they watched them for a while. And they needed to have a lot of people. If you give 10 people the vaccine shot, nobody gets COVID. That doesn't really help, because out of 10 people, usually no one gets it anyway. So you did have to have a big group. And what they wanted to do is they wanted to see whether or not the proportion of people who got the vaccine who also ended up getting COVID was significantly lower than the proportion of people who got the vaccine who didn't get the vaccine who got COVID. And that's how that was the big study, okay, like of the last few years. Hopefully everyone. There's been lots and lots of studies, but that's the biggest one, in our, last couple of years. Any questions on the idea? Okay, so the first thing you have to do is come up with the null hypothesis. And because this is something I don't remember exactly, but what percentage of people do you think would get COVID within a month a year and a half ago? Just throw in a number and I'll put that up there. Okay, so 5%. I'm going to say 4%. Because 5% is going to be confusing later on for something. We're going to use that for something else. So I'm going to go for 4%, just so I don't confuse you all. Okay, so let's suppose that 4% of just regular people get COVID, okay, or got COVID. Then what you would do is you would state the null hypothesis. And the null hypothesis, let me insert equation, is the following. So hopefully you all know what's the first letter of hypothesis. Not a trick question. Yeah, H. Okay, now they use capital H. So they always use capital H. And for null hypothesis, it's H sub 0. Okay, the British got to this first. And 0 is not a word in Britain. So it's H naught, because that's how they say 0 in Britain. So everyone calls it H naught. And then colon. So just note, it's always going to look like this. The null hypothesis always has an H, the sub 0, which in Britain you call naught, and that's what we use, and then a colon. Then you have to decide what kind of variable this is. So there's a biggie in this class, and pretty much for the rest of the class, you should be asking yourself, what's the survey question? What are you going to ask this person who, you know, a month ago you gave the vaccine to? What are you going to ask the person? Yeah. Did you get COVID, right? And the answer is yes, or the answer is no. So it's really important anytime you're doing an H naught and H1 and also confidence intervals, you start out by saying, is this a yes, no question? Or is this a quantitative question where the person would say a number? Okay, and then by the way, there'll be a chapter where we have none of the above, where the answer might be some red or something. For a while, we're going to have yes, no, and quantitative. This is a yes, no question. And when you have a yes, no question, the variable you use is P for proportion. So I'm going to type in P. Okay, on the other hand, if it was quantitative, you don't use the letter P, then you use the letter mu. Okay, and by the way, in Google, if you want to do mu, I've inserted an equation. You hit this button here, Greek letters, and mu is right here. Okay, we're not going to use mu because this is a proportion question. Any questions on that? So we're going to say P is equal, and then we're going to write down kind of the status quo, and we're going to say, well, let's suppose 4% of just everyone gets COVID. You'd say 0.04. I'm going to make that bigger so you can see it better. Any questions on the null hypothesis? This is called the null hypothesis. Any questions on that idea? Okay, then we're going to have what's called the alternative hypothesis. So the null hypothesis is really what you're trying to show is not true, right? If you're, if you're the, Pfizer, you're not trying to show that your vaccine doesn't work, right? You're trying to show your vaccine does work. So in this case, if the vaccine does work, the first thing is we're going to have an H for hypothesis. And there's actually two things you'll see. I usually will write 1 for the alternative hypothesis because you have 0 and then 1. Sometimes you'll see A. So just be ready for whichever. And A stands for alternative, or 0 and 1 is the next number, and statisticians haven't agreed on what to do. So you'll see both of them. And then colon, just like before. And then P. Now, what was Pfizer trying to show? Yeah, Pfizer's trying to show that it's effective, and being effective means you have a smaller chance of getting the COVID if you get the vaccine. So it's going to be less than 0.04. Okay, and I will let you know this is elementary statistics. You know, the whole story of what they're doing is a lot more complicated, but we're sticking to just the elementary piece. So before you quote me that this is all Pfizer did, that's not true, but this is a piece of what they did. So if it's effective, then it should be less than 0.04. There are a whole lot of other things they made sure of, because again, if no one's getting COVID, but they're all dying of cancer, well, that's probably not good. So there's other things that they wanted to make sure of, side effects and stuff like that, which they did, by the way. Okay, any questions on what's called the null hypothesis and the alternative hypothesis? So let me write down those words. Any questions on setting this up? So just to let you know, the null hypothesis will always have the equal sign. That's just part of it. The alternative hypothesis will not always have a less than sign. What else could it have? Hopefully it's kind of obvious. Yeah, it could have a greater than, and it turns out it could have a not equal to also. Yeah, it could have a not equal to. So an example of that is, let's suppose you're looking at blood pressure. You want to find out if someone's healthy or not. So the idea is the alternative hypothesis would be that mu, now be mu because blood pressure is a number, it's not a yes or no, is not equal to, and by the way, I am not a doctor or nurse or anything like that. I have no idea. Anyone know what blood pressure is supposed to be? Give me a number. Because I know some of you. Okay. All right. So I'll just go for the 120 because again, I don't know enough about, don't pretend, I do not know everything. I know statistics. So I just go for 120. And the idea is it's not equal to 120 would be bad, right? Because if it was way high or way low, then the person has real bad health issues. That I know, by the way. A 0 blood pressure is probably bad. For example, if you're dead. And super high is bad too. So sometimes you do not equal to, and that's called a two-tailed test because not equal to has left-hand side bad and right-hand side bad. Does that make sense? Less than is going to be a left tail test because less than on the number line, those are small numbers, those are on the left side. And greater than is a right tail test because those are big numbers and they're on the right-hand side of the number line. So that's just some of the vocabulary, and you'll read in the book and see all that. I can't write it all out because it takes too long, but I can say a lot of it. So you can have three types of tests: left, right, and two-tailed. This is the example of a left tail test, this COVID one. Any questions on this idea? Okay, the next step, and again, the order is important. Okay, you should never do the hypothesis after you've looked at the data. That actually is wrong. It's unethical. Okay, it's unethical, and you're going to end up with wrong answers, not just on a test, but in life. So if you're in medicine, you're going to kill people, and there's nothing worse than that. Okay, you're going to end up thinking your medicine works and it doesn't, has no side effects, and then you kill people. So it's always you do a hypothesis before you do the test. You could do a preliminary test, then you write your hypothesis, and then you don't use any of the data from the preliminary test. Then you start over and you get new data. That's okay. Any questions on kind of the ethics and the idea of the order at which we do things? Okay, the next step is state the ramifications of a type 1 and type 2 error. So let me ask you, do you guys know what the word ramification means? So I've learned that some people don't. That's an English word, not a math word. Yeah, implications. I like to think of it, because we're talking about errors, bad stuff that happens because of it. Okay? What bad things are going to happen because of that error? And really, that's what we're looking at. Okay? So let me define the type 1 error. That I didn't expect you guys to know. Ramification is a word that is an English word. Nothing to do with statistics. So type 1 error means the following. That means we end up rejecting the null hypothesis when the null hypothesis is true. So for the COVID, for the Pfizer shot, the vaccine, what are the ramifications of a type 1 error? What bad stuff is going to happen? Or would have happened if there was a type 1 error? Okay, you say deaths, but why would there be deaths? Because most people don't see why there'd be deaths. Okay, not bad side effects, actually. So here's the reason why there'd be more deaths, but it's very indirect. It's not obvious why there'd be more deaths. So what a type 1 error would mean is that everyone would think the vaccine works, and it doesn't. So the reason why there'd be more deaths is all these people got vaccinated. They're told, now you don't have to worry about COVID anymore. So then they go out to the big party, don't bother with masks because they're vaccinated and they think they're wonderful and safe. And then they get COVID and die. Does that make sense? So that's a ramification of the type 1 error, is that people think that it works when it doesn't. So then they're going to be less secure and not wear masks, for example. Okay. Any questions on that? Okay. A type 1 error in medicine actually is called is really a false positive. So you think it works and then it didn't. So then there's a type 2 error. Okay, and I want to let you know, it's just like the court system. When we actually found, we were not able to find the person guilty of the crime. Okay, it's a long story. I can't get in. I mean, I could get into it, but I don't have time to get into it with you guys. But we weren't able to find the person guilty. Does that mean we know the person's innocent? Does that mean we decided the person was innocent? Yeah, it doesn't mean we decided the person was innocent. It meant we decided there wasn't enough evidence to show guilt. I think the person was probably guilty, but if there's no evidence, you can't put him in jail. Does that make sense? So similarly, with hypothesis testing, you either find him guilty, or in other words, say that what you were trying to show is correct, or you say you don't have enough evidence to make any conclusion. And in the court system, if you don't have enough evidence to make any conclusion, the person goes free. Does not mean the person was innocent. Okay, so very similar to this. So we don't say, we say that the null hypothesis was correct, because you never say that. We say that there is not enough evidence to reject the null hypothesis. Sometimes we call that fail to reject the null hypothesis. when the null hypothesis was false. So the alternative was true. Okay, so now let's think about a type 2 error and what are the ramifications for the type 2 error for Pfizer's COVID vaccine test. What would happen with a type 2 error? So it's very different. Yeah, except thinking, you don't think the vaccine doesn't work, that would be accepting H0. Instead, you can say the FDA does not approve of the vaccine, which does not mean the vaccine doesn't work. It means there wasn't enough evidence to show it works. So everyone see the difference? Okay, but the vaccine works. And what are the ramifications of that? Let's see. So the ramifications are we're not allowed to get vaccinated. Okay, so when the vaccine really did work, so people die of COVID when the vaccine would have prevented death. Any questions on that? Okay, and I'll let you know, anti-vaxxers are right now committing a type 2 error because they have decided to fail to reject the null hypothesis and say, I'm not trusting it, I'm not getting vaccinated. And there's a lot of anti-vaxxers who are dying of COVID. I talked to the nurse at Barton Hospital. If you're not from Tahoe, that's our hospital here. And she said every single patient she has had who was dying of COVID was not vaccinated. And she didn't have any that were vaccinated. And that tells you something. So, you know, that's one of those that they have committed a false type 2 error and are dying because of it. Okay, because by the way, the sample size originally was 20,000 or 10,000, sorry, 20,000. But now things have changed. What's the sample size for the Pfizer, you know, or Moderna? Yeah, if you look at all combined vaccines, it's actually over 1 billion. Yeah, it's over 1 billion because there's 8 billion people on Earth or so almost. And a lot more than 1 in 8 have been vaccinated. So that sample size is so big. So is there ever enough evidence to say the alternative hypothesis is true? Never in this class. But if you have not even 1 in a quintillion chance of being wrong, then that's enough to stake your life on it. Some of you probably don't even know what the word quintillion means. But that's what we're talking about for a COVID now, the COVID vaccine. When you have that kind of big sample size, that's what we're talking about. It's so big that you don't even know that number. Okay, so that kind of stuff happens. Any questions at all on type 1 and type 2 error? Any questions? Okay, so I want to tell you the next step. The next step is the hardest step. What's the next step? Yeah, the testing, right? I mean, finding the type 1 and type 2 error, that takes 10 minutes, right? Maybe less. But to do a test of 20,000 people with the COVID vaccine, that is hard. Okay, that takes a huge staff. It takes months of work. That is really tough. So in the real world, you got to get all the rest right because you don't want to screw up and end up wasting months of work because of the 10 minutes that you didn't do it right. So that's just a note. So the next step is to collect the data. And again, we're not going to collect data of 20,000 people. I can't make you do that. But that's the real world. They collect the data. Then after collecting the data, so maybe I'll write that out for the steps. Sorry, before we collect the data, one more step, sorry. So right after you do the type 1 and type 2 error, what you have to do is you have to decide what your level of significance is. And the level of significance is the probability of a type 1 error. So you'd think, well, why don't you decide on 0.00000000001 because you don't want a type 1, you don't want an error, right? And there's a problem with it. And the problem is the smaller the probability of a type 1 error, the bigger the probability of a type 2 error. So you can't have everything. The only way you can have both low is a large sample size. And the hard thing about a large sample size is, I told you the hardest part of the whole statistical process is collecting your data, and sometimes it's unethical even. So for example, if you did a sample size of 1 billion people for the COVID vaccine, and it turns out it kills everyone who gets it, that's not okay. Do you see how it works? So usually you start actually really small and then build your way up until you get a big enough sample to actually have good data. Because again, you don't want to risk killing everyone in your group for the vaccine type of stuff. Okay, so you have to decide on, that should be level of significance, even Google knows, the significance of the probability, that's right. So you have to decide on the level of significance. The standard is 5%, or 0.05 is another way of writing it. In our class, just like we did with confidence intervals, in our class, we'll stick with 1%, 5%, and 10%. Again, there's elementary stats, so I'm trying to keep it elementary. Any questions on that? Okay, so you decide on level of significance. I will let you know in, just like for confidence intervals, if it's anything in psychology or sociology or news, for good news. Facebook, you choose no level of significance because who cares? You just post it. But I'm talking about real news. 5% is what everyone uses. But if, kind of there's lives depending on it, you have to decide what's going to kill more people, the type 1 or the type 2 error. And then you go up or down depending on it. Any questions on that? Okay, but if the only thing that matters is reputation, then 5% is what everyone uses. If type 1 and type 2 is all about reputation and that's it, 5%. That's standard. Any questions at all on the deciding on the level of significance? So in this case, by the way, what do you think? Which is worse, the type 1 or the type 2 error, or are they about the same? Yeah, it might be about the same because either way, you're going to have people dying. You'd probably spend a lot more time than 5 minutes thinking about it because it is important. But if they're about the same, then you go for the 5%. Any questions on that? Let's see what Colin asked. There's a lot of things. Could you explain the trade-off between the type 1 and 2 type? Yeah, so if the type 1 probability of error goes up, the type 2 goes down and vice versa. As one goes up, the other goes down. It's too complicated for me to show the mathematics of it, but you can trust me on that. So it's a give and take. So if type 1 is really bad, is a lot worse than type 2, then you're going to use like 0.01. You want to make that smaller. Whereas if type 1 is not as bad, then you're going to let this level of significance be higher, like 10%. Any questions on that? And if they're both really bad and you can do it, then you just have a bigger sample size. You know, but the problem with bigger sample size, it takes more time. And if time is an issue, you got to think about that too. Any questions on this? Okay, and a lot of times, and this is from my experience, your boss tells you what you need to use. So when I did consulting work for the Forest Service, they told me what the level of significance should be. And I said, okay, because the boss is always right. I explained what it meant. And they said, yes, and we still want it to be 10% is what they wanted. So that happened. It was some years ago, but it happened. Okay, any questions on this idea? Okay, once you decide on the level of significance, then you collect your data. Okay, and you should not decide on the level of significance after you collect your data. You should never look at the result and say, well, I'm going to change the level of significance so I could be right. That's unethical. Okay, whereas confidence intervals, you can do that, but hypothesis testing, you can't. Just let you know that. Because with hypothesis testing, you make a decision when you're done. Confidence intervals, you state the interval and you say, here, but there's a 5%, a 95% confidence. So, that then everyone knows what that means. Whereas with hypothesis testing, you're making a decision. You're putting someone in jail because you found them guilty. You're giving everyone the vaccine because you found that it was safe. You can't just change your mind later. So it's a decision making. Any questions at all on the next step is collect the data and the order at which you do things. Okay, the next step. Put the data into the computer and calculate the p-value. Okay, now again, I don't expect you to know what I just wrote or to understand it, but let me explain what this is. So the p-value is the probability that if the null hypothesis was true and you did a study with the same sample size, unbiased, then you would end up getting something as significant as your results or as unusual as your results. Okay. Don't people change their significance level after collecting the data? Not if they're ethical. That goes against ethical. That'd be like saying, don't people change their data so they can, just kind of pretend that the person said 23 when they really said 4? Yeah, of course that happens, but I'm teaching you to be ethical. That's my job. So I'm not going to even go there. Don't cheat, don't lie, don't do that kind of stuff. Okay, and if you're working for a third-party group, then there's no reason to be unethical. So FDA is a third-party group. They do the test, and there's no reason for them to change. Unless Pfizer pays them enough and they do it behind it, but we're not going to do that. Okay, so then we're going to compute the p-value. Okay, and that again is how unlikely it would be if the null hypothesis is true that you get such extreme data that you got. So the next step, compare the p-value with the level of significance. If p, so now I need to write it in symbols. If p is less than, who knows how to read that letter? The Greek letter, it's the first Greek letter of the alphabet. Yeah, alpha. Key word is alphabet. That's why we call it the alphabet, because it came from Greek originally and it was alpha. Okay, so it's the Greek letter is the level of significance is alpha. If p is less than alpha, reject the null hypothesis and accept the alternative hypothesis. If p is greater than alpha, fail to reject the null hypothesis. Okay, and when you fail to reject the null hypothesis, really there's two reasons that could have made that happen. One reason is you were just wrong. You had this idea, you wrote down your H1, and it was just wrong. You know, the vaccine just doesn't work. Another reason that happens often is your sample size is too small. Because if your sample size is too small, then you're not going to have very good data. So you have to decide if you think that it might be the case that the sample size is too small in the real world, then you redo the experiment with a much bigger sample size. Cross your fingers because you got to work much harder with the bigger sample size. You don't keep using the same sample size because if there's a 5% chance of a type 1 error and you do it 100 times, 5 of the time you're gonna end up showing that you were correct when you really weren't. So that's bad ethics. So you typically have to make a much bigger sample to see if you might be right. Any questions on this? Okay, so I want to show you an example, a real example, and I want to do it because it is something that, first thing, it's new in the news. Hopefully you all know what happened 2 days ago. Super Bowl, right? And I'm not a sports fan, by the way. I'm not a Super Bowl fan, but I knew the Super Bowl was happening. And so I found an article that talked about it. And so let me show you what you're going to have to do for your discussion assignment, because this is new. Okay. Previously, all I said is go find an article, right? Now, I want to make sure that that article has been peer reviewed in a journal, because I want you to understand true good research instead of a company that's making money and that's all they care about. Okay, so, and peer review, by the way, what that means is that you have your idea, you know, you have all your evidence, you write it up, you send it to the journal, and then the journal sends it to 2 experts in the field called peer reviewers. And they read the journal article, and if it is done correctly and worthy of publication, then they give it a thumbs up and it gets and it gets put in the publication. Whereas if the peer reviewers think that it wasn't worthy, you know, it was bad data collection or just wrong statistics or just not relevant, then it doesn't get published. So if you didn't know, that's how peer review works. And I am a peer reviewer, by the way. So I've been on that side of it. I'm a professor, and Professors are the ones that typically peer review. Okay, I'm the peer reviewer for open educational resources in mathematics because that's my expertise. So that's in a peer-reviewed site. So that's how it works, which means that you're not going to just be able to go to Gallup or Pew. Those are not peer-reviewed. So let me show you how you can do it. Okay, you are going to go to Lake Tahoe Community College's page. There's other things you could do, but this is the safest. You're going to go to library. You're going to go to find articles. If you're on campus, you just do that. And then you're going to hit academic search complete. If you're at home, it's going to ask you for your username and password, which should be the same as what you use for Canvas. And you type that in. And then search for what you're interested in. Okay. So just to let you know, I found something. And what I did is I actually found something and I wrote down the title of it. And that is Portrayals of Minorities and Women in Super Bowl Advertising. So it was an interesting article and it had what I needed to show. Okay. So when you find something, don't copy the link and post it onto the discussion board because the link doesn't work. So that's a warning. Copy the title of the article and then you'll find it in the Lake Tahoe LTCC library search. So if I write portrayals of minorities and women in Super Bowl advertising, and I put it in there and I hit search, then there it is. Okay. And there was only one article with that title. Okay. But if you want to search for things about Super Bowl, you just type Super Bowl and look for an article that works. And when you search, by the way, see this peer reviewed? Click on it. And then it'll make sure that the result will be peer reviewed. Okay, because again, this is a college course, which means you should understand what it means to have a accepted journal article. Doesn't mean you have to write an accepted journal article, but you should understand what it means to be a journal article. So for peer reviewed, I clicked on, it said peer reviewed and there was a place to click on. And then search to find it. Then I click here and I'm going to click, I don't know, PDF text will work, HTML, it doesn't matter, whichever you want. And I want to show you, again, the last thing I'm going to do is read a 39-page article to you guys. But I wrote down, it was page 15. Under gender, and let me read what it had to say. And what it said is, as can be seen in table 2, there's a table here, males were featured as principal characters in a higher percentage of ads than females, 86% versus 14%. Okay, now, again, this was a sample, and samples may not represent the whole population. But now they continue on, and let me read this piece right here. Hence, female and male models are not equally presented in Super Bowl ads. P is less than 0.01. And when you read a journal article, they will always cite the p-value when they do this kind of study. So this is how it looks when you look at professional articles, is you're going to see the p-value. And if you don't know statistics, you'll have no idea what they said. But the hope is by the end of maybe this week, or at least this class, you'll be really confident about what p-values are all about. So p is less than 0.01. Is that small enough to reject the null hypothesis? in this class? Or anywhere, actually. Yeah, the answer is yes. So first thing I told you in our class, the lowest number we'll use is 0.01. Highest is 0.1. And the standard was 0.05. I also told you in sociology and media and that kind of stuff, and that's what this is, right? This is not where they're giving medicine to someone and might kill someone. This is just an article about, gender bias, which is really sociology. And in sociology, 0.05 is what they use, so P is small. Okay, and sometimes if it's less than 0.01, when they give the conclusion, they say there is strong statistically significant evidence. Whereas if P is somewhere between 0.01 and 0.05, they'll just say there is statistically significant evidence. And if it's greater than 0.05 but less than 0.1, they'll often say there is only weak evidence. And if it's greater than 0.1, they give up. They said we weren't able to really find anything. And that's kind of standard in language. Any questions on that? Were they studying the sample of the population? Very easy to know, because if they were studying the population, then there is no p-value, then they know with 100% certainty. Do you see? So you don't even state a p-value. Like, I know with 100% certainty that it snowed last night in Tahoe. There's no reason to talk about a p-value. Okay, there's no reason to do a study, because I know it snowed because I walked outside and got to ski in powder. So if you know the whole population, then it's just a fact and you don't do statistics. Okay, so this is just for samples where you don't know. Any questions on that? Okay, so that's the idea there. Okay, but I thought I'd show you a real article. Okay, I didn't write this. Okay, and I wouldn't. I know very little about Super Bowl, but I know how to read P. Any questions at all on this example? Okay, so now let's go back. And here's another example. Okay, and this is something that I've done. I know there's a group of you that are in Tahoe. I know there's some that aren't, right? If I remember right. I don't know about who's here. Something I participate every year is something called Snapshot Day. Anyone heard of that? What that is? Again, if you're not from Tahoe, you have no idea. So every year, they have a group of volunteers. I'm the volunteer. And they have us collect data in the streams to see if things are getting more or worse in terms of pollution and, how good the quality of the water is that's flowing into Lake Tahoe. And pH is one of the readings we do. So you've probably heard of pH. And one question you might ask is, does the average pH in streams that flow into Tahoe differ from 7? Right, 7 is neutral pH. And if it's, by the way, if it's much below 7, then it's acidic and that's bad. If it's a much above 7, then it's basic and that's bad. So you want it to be pretty close to 7. Okay, so we take the readings. And again, it's impossible to do a population because that would mean you'd have to do every molecule of water over time forever. That's never going to happen. So we take readings and there's a group of us that do it. Sample size is decent because there's pretty many volunteers. And then we state H naught and H1. So H naught is, notice this is a mu and not a P, because if we're talking about a mean, we're talking about the pH is a number. It's not a yes, no, it has pH. It's a, pH was 6.1 or something like that. So mu equals 7 and H1 mu not equal to 7. Any questions on that? Okay, so this is a two-tailed test because it's a not equal to. So then we look at the type 1 and type 2 error. So a type 1 error means that we reject the null hypothesis when the null hypothesis is true. That was our definition. So in this case, they're going to publish that the population mean pH is not 7 when it really is. So what's going to happen is they're going to say, oh no, we're destroying Lake Tahoe. We're going to need to get millions of dollars to fix the problem, when there was no problem. Big loss of money. Do you agree? Okay, so that's bad. Okay, whereas a type 2 error is you fail to reject the null hypothesis when the alternative hypothesis was true. So in that case, you don't have any evidence to show there's any problems. So you're not going to be able to get money from the government or from, nonprofit organizations or whatever to deal with the problem when there really is a problem. So you're just going to let it go. And what's going to happen is all of a sudden, Lake Tahoe has really a high pH or a low pH, and all of the life in the lake dies out. That's bad. Okay, which is worse? So they're both pretty bad, right? That depends on your political feelings, right? Some people don't want to pay more taxes. Some people want to protect the environment. And I try not to get political, by the way. But let's suppose that was, it was about the same, paying more taxes and protecting the environment, that kind of stuff. Then you could choose 0.05. Okay. Whereas if you think that it's more important to protect the environment, then that means you really don't want a type 2 error. So a type 2 error is worse. So in that case, you're going to use 0.1. Okay. Whereas if you're one of those anti-tax people, you're going to use 0.01. Do you see? I'm going to do my way. I'm an environmentalist. So sorry if you don't like me, but I do believe in protecting our lake. To me, that's most important. So I'm going to choose 0.1. Any questions on that? All right, so then you get your p-value. And I think I'll show you, again, we only have so much time, but if we go to the LibreText calculator. As I mentioned in the orientation, actually, it was already like 6 weeks ago, that I put these in order at which we do things. So we just finished confidence intervals and now we're in hypothesis testing. So now we're looking at hypothesis tests, which is now 14, 15, and 16. So, and the way, for example, when I actually did the work on this, okay, and as you might guess, because I am an environmentalist, at the end of it, I talked to the people in charge and I said, I'd love to volunteer and help you do the statistical analysis, because I thought I could, do a positive thing, because that's my expertise. So I actually did it, okay, at least a couple of years, and did the statistical analysis for them, and was able to help them understand what the data gave. So in that case, we had a hypothesis test for a mean with data, because we had the data of all the pH readings that all the people had taken. And I'll just make some stuff up. Let's say it was a 6, 7, 6.5, 4.2, super acidic or more acidic, 5.1, 7.8, 6. And let's suppose it was that. Again, we had a bigger sample size, but don't waste your time. And then we can go to, if you happen to know the standard deviation, which in the real world you never do, we can leave that blank. Okay. And then we were doing, in this case, a not equal to for the test. Our mu naught was 7. That is the hypothesized mean. That's what's on the right-hand side of the H naught. The mu equals 7, and it calculates. Okay, so with this data, the p-value is about 0.0882 or 0.09 or so. Any questions on that? And then you go back, and if that's your p-value, and we use the level of significance of 0.1, notice 0.08 is less than, or 0.09 is less than 0.1. And if the p-value is less than the level of significance, you reject the null hypothesis. And you say, I have statistically significant evidence to show that the pH, the population mean pH of the inflow into Lake Tahoe differs from 7. Any questions on this idea? Okay, and I made these numbers up, just let you know, in the real world, when we did it, there was over 100, we had much bigger sample size, is a whole different thing. But you would never do this experiment because the sample size is too low, and there's no reason to believe that pH is normally distributed in the streams that go into Tahoe. No one has any idea about that. So what you do is you get a big sample size. Any questions on that? Okay, so that's the idea. Okay, so let's suppose, again, when I did, it was 0.004. You know, that was reality. And we want to talk about the conclusion, and that is there is statistically significant evidence. I'm going to put that in red also. There is statistically significant evidence to conclude that the population mean pH, notice the word population mean has to be there. If you don't put it in, what's going to happen? If you don't put the words population mean in, whether it's your project or, yeah, you're going to lose points. And I want to give you a warning because I saw this on some of your answers to the exam. If it was a yes/no question, do not write population mean. Then you write population proportion, or you write percent of all. Okay, make sure that you use the right vocabulary, whether you're in mean or proportion land. Okay, don't make that mistake, because a lot of people made that mistake. So I'm going to keep saying it because I don't want you to make that mistake. Okay, this is a population mean because it was the mean pH. Okay, whereas with the COVID one, that would be a population proportion because that was a proportion of people that got COVID. Any questions on that? Okay, so that is very important. Okay. Now, if we want to interpret the p-value of 0.004, here's what we say. If, let me make it bigger so because it's important. If the population mean pH is 7, okay, and if we conducted another study, just one other study of 583, because that was how many we looked at, by the way, water samples from many creeks, then there would be a 0.4%, because 0.004 is 0.4%, chance that the sample mean would be either less than 6.9 or greater than 7.1. Okay. So just to let you know, in this case, in our real data, it was 6.9. And the way you get 7.1 is 6.9 is 0.1 less than 7. And there's a two-tailed test. So the other side would be 0.1 more, which would be 7.1. So a lot of people have trouble with that. So, you know, I'm recording this so you can listen to it again if you have trouble. Okay. So Any questions at all on interpreting the p-value? A lot of people have trouble with this. Okay, now to interpret the level of significance, that's the 0.1, which again is the probability of a type 1 error, starts the same. If the population mean pH is 7, and if it conducted another study of 583 water samples from many creeks, then there would be a 10% chance, 0.1 is 10%, 10% chance that we would end up falsely concluding the population mean pH differs from 7. Basically, you restate what a type 1 error is. And you say that's the chance of a type 1 error. Any questions at all on these examples? Okay, I only have so much time, so I always have more examples than I can. But I have a template for you. And that is, there is statistically significant evidence to claim that the population, and I'm not going to write, I think I want to change that. It could be mean. What else could it be? What other word might happen? Proportion. ... Okay. So it really depends on the situation. In this case, that the population mean is not equal to 7. But if it was the COVID one, it would be the population proportion is less than 0.04. You see? Or you could say the percent of all people, all vaccinated people who could get COVID would be less than 4%. But you have to you must specify you're talking about everyone. Okay. Any questions on that? Okay. And then similarly, for failing to reject, then you say they're statistically insignificant. No, well, IN. Really, the only difference is the IN. So there's statistically insignificant evidence to support the claim that the population and then whatever. And that's a template. Okay. And please do not copy and paste the template and don't change the X's. That stuff happens. So make sure you know X's mean you put your stuff in. Any questions at all on this example? Okay, and the p-value interpretation is if the null hypothesis is true, but if it's in parentheses, you need to talk about what the null hypothesis is. So in this case, if the population mean pH of water going into Tahoe was 7, and another sample of however many you surveyed was taken, then there would be whatever the p-value probability is, and then the results of the new study would be at least as extreme as the results of the study you got, but you need to turn that into the context of the question. If it's in parentheses, that means you need to put into context. Any questions? Okay, and level significance template is if, again, the null hypothesis is true, whatever that null hypothesis might be, and another sample of however many were taken, then there would be whatever your level of significance is, probability, that the new study would result in falsely concluding that, and then whatever the alternative hypothesis true statement could be. Any questions at all on this situation? Okay, again, we don't have time for lots of examples, but I do want to give you a secret word. And the secret word is if. Any guess on why I chose that as a secret word for this week? Okay, I don't see it, but if you look at the p-value or level of significance template, first word is if. So that's why I chose it, because it gets you started. Get you started. I will let you know, just like confidence intervals, the conclusion, I'll always ask you for a conclusion. The p-value and level of significance interpretation, I'll sometimes ask you. So be ready for that. Don't get them confused. They're not the same things. So any questions at all on hypothesis testing? All right, so just let you know, the rest of this entire class is mostly about hypothesis testing. So if there's anything you don't understand, please ask. There is a Q&A forum, and you post it, and I'll definitely answer. Okay, and I check it pretty often. But don't expect to answer, 1 second after you post, because even if I'm looking, it takes me a while to type. But sometimes, I'm sleeping or like today, we got powder on skiing. But I do check every day and multiple times per day. Okay, so anyway, now that we've seen confidence intervals and hypothesis testing, we're ready to start thinking about the project. So I want to jump to the syllabus. Okay, and it's in a few places, but I think it's easiest to just click on project 2. So this is what project 2 is all about. So the first thing, by the way, similar to project 1, is you are absolutely required to work in a group. Recommended 3 people, but 2 is allowed. So if you don't have someone, please post. And if you only have 2, please look in the project discussion board and say yes to someone who's asked for a partner, because I think we had one this week. So if there's only 2 of you, please accept a 3rd person in. So not only are you doing a nice thing to someone else, but you're also making it so you don't have to work as hard, because now you get to make that person write a 3rd of your paper. So go for it. So I definitely want to do that. So that's the first thing, is that there's a group project, just like before. But this is not project 1. So project 1 emphasized the data collection. It emphasized the statistics and the charts. Project 2, you can briefly mention those things, but very briefly. Don't spend a lot of time on any of that. Okay. And to let you know, unlike project 1, so for project 1, you had to use, remember, pretty much cluster sampling or stratified sampling. It's simple random, but that never worked. You can never do that. For project 2, you can do whatever you want. And you don't have to ask people even. Okay, so project 2, you can collect data by finding it. So for example, you can go to the supermarket and get a bunch of prices, and then go to another supermarket and get another bunch of prices, and that's it. So you don't have to ask anybody anything. You're welcome to if you want to, but you don't have to. Okay. Here is a rule though. If you can get the population mean, then this won't work for project 2. Because project 2 is all about confidence intervals and hypothesis testing. And if you know the population mean, then it's worthless to do a confidence interval hypothesis test. Because if you know the population mean, you're 100% confident about that population mean. So there's no reason to even do those things. So make sure that, again, if you can, and when I say you can get it, let's say if you can get it in less than 2 hours. Sound good? So I don't mean if it's theoretically possible, but if it's practically possible to get it. So for example, if you were doing if you wanted to find out this year, which league did best in football in terms of most points or something. That's something you could just get, right? In very short time, you can find out how they did in football. So that wouldn't be a good project because you can get the population. Does that make sense? Okay, but there's a lot of things you can't get. There's just a sample size way too big and it's not going to happen. And no one's actually collected it. Okay, so that's one piece, is that's what we're talking about. So again, the purpose is to use confidence intervals and hypothesis tests. Okay, to support or show lack of support for a research project. Any questions on that? Okay, so like project one, you have to identify a client. Okay, so you have to identify a client, and like project one, it doesn't mean you have to get the client's actual permission or even know the person. So if your client is President Biden, that's fine. Okay, even though good luck trying to call Biden and get him to say yes. But you could pretend he'd be interested. Does that make sense? Okay, so again, so you have to have a client, and that helps you identify the needs for the project, because that's a big part of the project. Okay, so once you've identified the client, the next thing you're going to do, it says next analyze your data, but that's much later actually. What you're going to do next, the next thing you're going to do is you're going to run a hypothesis test. What's the first step in running a hypothesis test? Yes, state the hypotheses. So here's what you want to do. The first thing you're going to do is not state the hypothesis in your project paper. Where do you think you're going to state the hypotheses? Not Q&A, in the project 2 discussion forum. That's where you're going to put it. So post your hypotheses in the project 2 discussion board. Got it? Not email me, because the reason why I want it on the discussion board is so that the whole class can benefit from the conversation. So they can kind of see what works, what refinements need to be done, so that they get good ideas too. Any questions on that? And that's kind of my rule, is that if it's going to help other people out, then you have to do so by posting. Okay, whereas if it's something personal, then you can email me, you know. So if you got COVID and you needed extra time on, you know, on an assignment, you don't post that, then you email me, and you know, I'll make that happen. But things like, will this hypothesis work? Here's my H naught and H1. That's something that's going to help everyone, and it's not personal. Any questions on that? Okay, so that's important. You're going to post on the project 2 discussion board your ideas. And I will tell you something, and this is a little early to tell you, but I want to tell you so you don't like make a mistake now. And that is, the confidence interval hypothesis come from chapter 10. So we don't know how to do that, or you don't know how to do that yet. So this is why I'm giving you a lot of ideas now. And chapter 10 is going to be a hypothesis test for the difference between 2 population means. So you're going to be doing that. You're going to be looking at possibly 2 groups and comparing them, or 1 group and comparing 2 things from that group that are both quantitative. Okay, and we'll see that next week. Yeah. Okay, so sample means, not population mean. The hypothesis is for the population mean. The data is the sample mean. Do you see the difference? H naught has a mu, not an X bar. Even though you don't know mu, you hypothesize mu, and you find X bar. Does that make sense? Yeah, very important. And you don't want to get those confused, X bar and mu. Okay, so then what you do is after you get the okay from me, is you collect your data. Okay, and again, that doesn't have to be a survey. That could be, looking at, I don't know, Amazon and eBay and seeing which is more expensive or something like that. Does that make sense? Okay, that's an example of a hypothesis test you would want to do, is that eBay is cheaper than Amazon. And then you would go find 31, by the way, 31 products that are both sold on Amazon and eBay, see what the prices are, and then you would test that hypothesis. Okay, you would state your H0, you state your H1, you would decide on your level of significance by looking at the type 1 and type 2 error ramifications, collect your data, and then get your p-value. I will also let you know that I think it'll be easy if I go this way for you guys. And I think it's here. Project spreadsheet resources and the Google Sheets. You can click this guy. And if you already did it, you don't have to recopy it because you have your copy. It's yours. It's not mine anymore. This one's mine because it's my screen. And I'll let you know, because you're going to be doing a difference between two means. That's the second tab. There's two var stats. And then there's going to be a first and a second column. So you're going to have the data for the first, and you're going to have the data for the second column. So if you're doing, say, Amazon versus eBay, then the first column would be Amazon, the second would be eBay. You type in the prices. Any questions on that? And then it gives you what you need to know. We haven't learned this stuff yet, so next week I'll be able to talk about independent versus dependent, but we're not quite there yet. So again, I decided to talk about the project now so that you get a heads up on it, even though you're not quite ready. So if you think you could finish the whole project this week, you're wrong, because we haven't learned chapter 10 yet. Okay, but at least you can start thinking about it. Okay, so again, it's going to be spreadsheet. And if you're doing independent, it turns out you go like this. You copy and paste, put it into your project. Okay, if you're doing dependent, go like that, copy and paste, put it in your project. Okay, unlike project 1, there's no requirement, no need to have any graphs and charts. So there's none of that. This is a different project. Okay, please ask questions if you have them. Okay, so you should talk about the sampling technique just briefly. Most of you can do convenience sampling, which is just fine. Okay, just be honest. That's the important thing, be honest. So say whatever you used. It's not fine in the real world, but this isn't the real world, this is a class. Okay, and I don't want you to spend all your time doing what you already did for project 1. Okay. You have to have sample sizes greater than 30. Okay, and remember there are 2 columns, so they both have to be greater than 30. So it turns out if you're comparing 2 groups, that means you're going to have 61 things. If you're asking if you're looking at 2 things for one group, then you'll have 31 in the group, but 1 of each, so that's 62 total. Okay, you could do more, but that's just more work than you don't have to do. That's up to you. Any questions on that? Okay, you can write down the summary statistics. Don't spend a lot of time on them. Okay, the only one that's important that you do need to spend time on is the one you didn't do in project 1, and that's standard error. And if you're having trouble with standard error, I created a video on what the standard error is all about. So watch the video and then you'll see standard error. Okay. But the main things are the confidence interval. So you're going to have to do a confidence interval. Unlike hypothesis testing, you can choose your level of confidence after you look at the different intervals. So what I recommend doing is looking at a 90%, look at a 95%, look at a 99%, state the pros and cons of the three, and then choose which one is the best for your project. And put all that in your project, in your paper. Okay. One thing that's really important is don't make this look like just an example. Okay. Don't just use the template. I want paragraphs on discussing it and what the client, how the client is going to use the information. So there's a lower bound for the confidence interval. How is the client going to use that lower bound? There's an upper bound for the confidence interval. How is the client going to use the upper bound? There is a margin of error. Is that margin of error appropriate and small enough for the client? Or should a new study be done, in theory, so that you can decrease the margin of error? Does that make sense? And what decisions will the client make based on these things? Any questions on that? Similarly, for the hypothesis tests, make sure you put it in the language of the client. Why will the client choose a, say, 0.05 level of significance? Don't just say, because it's standard. Because there's a client that cares, and standard isn't good enough. Okay? So make sure you really talk about the type 1 and type 2 error and how is it going to hurt the client. Do you see? What damage will be done to the client if you have a type 1 error for this project which the client paid you for, in theory. Okay, and type 2 also. Any questions on that? Okay, you're also going to look at the level of significance, talk about the repercussions, and also you're going to find the p-value. Interpret the p-value. I do want to let you know something about the p-value. If the p-value is, let's say, 0.001, are you satisfied? If the p-value is 0.001, are you satisfied? Okay, the answer is yes. Remember, your goal is to reject the null hypothesis, right? You're trying to show this thing is correct. So your goal is to reject the null hypothesis. If your p-value is 0.001, that's smaller than any level of significance you're going to use, you're very satisfied. Do you see? And if the p-value is 0.001, there is no chance of a type 2 error. How come? So let me give you an example. Last week, I tested for COVID. Test came out negative. Should I worry about a false positive? No, I tested negative. Okay, if your p-value is 0.01, you rejected the null hypothesis. Type 2 errors can't happen anymore because type 2 error means that you failed to reject. And the H0 was incorrect. But if your p-value is 0.01, you didn't fail to reject. Do you see? So after looking at the p-value, you revisit the type 1 and type 2 errors. One is still something to worry about, and the other is not something you worry about anymore. Does that make sense? Okay, now if the p-value is 0.01, should you worry about a type 1 error? The answer is yes, but not that much. Because 0.01 is very small. And if it's very small, then you can be really confident that you've got it. Do you see that? Whereas let's say your level of significance was 0.05 and your p-value was 0.04, then you have a much bigger concern of a type 1 error. Because yes, you were able to reject the null hypothesis, but you were on that borderline, you were close. Do you see? So it's a bigger concern. Okay. But if the p-value, let's say the p-value was so by the way, if the p-value is let's say 0.04, should you do a bigger sample and try again? Okay, let me give you an analogy. I like this analogy because it works well. Let's suppose you're playing soccer, right? Maybe you're the coach, and your team is up by 1 point. Got it? Your team's up by 1 point. And the other team, your player goes to kick the soccer ball and the other team just knocks him down and the referee doesn't call a foul. And then they call the game, it's over. Do you go and scream at the referee? Right, there's no reason to, you won the game. You go and have your champagne. Do you see? So if you have a 0.04 p-value, there's no reason to do another test. Do you see? For you, there's no reason to conduct another study with a bigger sample size. Let someone else do it if they want, but you don't need to. You have evidence, you're happy, you celebrate. Okay, what if you have a 0.05 level of significance and your p-value is 0.06? Do you think you should do a bigger sample size? Okay, so that was a yes. And the example on that with the soccer is now you're behind 3-2. Your player goes to kick the ball. The other team knocks him down. The referee doesn't notice. Then you go scream at the referee. Does that make sense? Because then you say, hey, we need to do this again. You screwed up, let's try again. So similarly, you lost, but not by much. So then you're hopeful that maybe it was just the sample size is too small. Okay, on the other hand, let's suppose your p-value is 0.8. Do you think that it's time to get a bigger sample and try again? If the p-value is 0.8. Not 0.08, 0.8. Okay, yeah, the answer is no. So I like the soccer analogy because it works on all of these. Now imagine you're the coach of the soccer game. There's 2 minutes left in the game. You're down 10-1. Your player goes to kick it, gets fouled, doesn't score, doesn't get the score because got fouled. The referee doesn't notice. Do you scream and yell at the referee? No, you're losing the game. Do you see? It's time to give up. Okay, so if your p-value is really big, you give up. You don't say, I just need a bigger sample size and I'm going to win. No. Does that make sense? So those are different scenarios. Okay, and there's nothing cut and dry like what level at which you would get a bigger sample size, but usually it's pretty obvious. Okay, any questions on that in terms of looking at the p-value? Okay, then you should talk about what assumptions did you make in finding your confidence interval and p-value. So again, you should talk about the pros and cons of a 90 versus 95 and 99 confidence level, and then choose which one. So make a whole big long statement about it, and make sure that you talk about assumptions on finding the interval and level. One assumption is there's going to be bias no matter what. There's no way to do it without bias. So talk about where the bias might come from. That's a short piece of the paper. Okay. And always discuss what you would do in further studies. Okay. Just like before, I strongly encourage you to send me a draft. Those of you who did, which is most of you, did it help? Did you feel like you had an improved paper because of it? Yeah, it makes a huge difference. Very few papers get A's if I don't see a draft first, because I'm going to be able to let you know what you need to change to make it a better paper. And very few people can make a perfect paper, almost perfect paper, without my help. Okay, and Braulio is happy to help also, right, Braulio? Okay, today is a longer day because hypothesis is a big thing and project 2 is a big thing. Okay, so last week was shorter, remember? Okay, and I will let you know officially there's a holiday weekend, but this is online, so what does that really mean? One thing is that if you come to the campus and go into like the tutoring, the library on Friday, you get arrested, because the only way to do that is to break a window and, you know, the alarm will go off. So the campus is closed, but I still check my email. Again, holidays are weird with online classes. But if you want to celebrate the holiday, then get all your work done by Thursday so you can take the long weekend off. So that's up to you. So I am going to stop the share and stop the recording. That's it.